In the previous episode, the students began to create a graph that showed the height of a fly as it traveled along a circular path. However, they related the fly's height with stop numbers rather than the fly's angle of rotation. In this episode, they will continue to work on creating a graph that shows the relationship between a fly's height above the midline and her angle of rotation as she travels along a circular path by plotting several points. They have begun by labeling the angle of rotation on their graph for 7 different stops. They will now mark in the height of the fly at those 7 stops.
So the 1 and the 2 and the 2.28 and 3.28 and 4.28 and so on and so on, what are those representing?
Like the radian measure at each stop.
Okay, so can you maybe just put 1 radian, 2 radian?
Can we just label it as being radians?
Oh, or R, it's fine.
Yeah, you do that. You do that.
Or label it as being radians. Mm-hmm.
Yeah. I'll just say radians per stop.
Okay.
And then
for this, we just need the midline in pipe cleaners.
okay.
The students have explained that the labels at the bottom of their graph represent the angles of rotation measured in radians. However, you will notice that there is the same amount of space between 2 radians and 2.28 radians as there is between 2.28 radians and 3.28 radians. The students noticed this and relabeled the x-axis so that each radian, not the stops, are equally spaced. Now they'll measure the height of the fly at each of the stops with pipe cleaners and use those pipe cleaners to plot the fly's height at each of the stops.
I thought we were supposed to cut them out.
Oh, I was just gonna do it all at the same time so I could cut it out.
Well, then in that case, I'll just measure from this line to this one and then.
So Claire, you're working on stop 6,
Yes.
and Mary, you're working on stop 3.
Yeah.
2 and 3
2
and
and 3.
like, yeah.
Okay. And then stop 4.
Yeah. And then I can do stop 5.
Can you sort of explain what the labels on your graph mean? Like what does the y-axis represent? What does the x-axis represent?
Okay.
Okay. So the x-axis is the radians, so we only measured the radians per stop, but it's in their exact measurements. I mean, it's in terms of pi, but
I see.
So this is 1 radian, 2 radian, and then since we have that little piece, so based on where we had our midline, this the small 0.28 piece is stop 3. So that's right there. So we just added the 0.28.
Oh, okay.
And then we just added more radians to that going on until stop 7.
Awesome.
Okay. So now.
Wait, we have to explain our y-axis.
We didn't do that one yet.
Oh,
That's why I was saying, because we had to put the pipe cleaners on there.
Okay.
And then we can explain it.
Okay. This is 1.
Yeah.
So
That'd be up there.
1, 2.
And then the 0.28 will be right next to it.
3.
There.
Then a little
Little 4. Little 3.28. It'd be here. Right under there. It's a little thing. It's okay. It's you're not gonna get that one perfect. It's just gonna move.
Isn't it a cutie? Like a little worm.
Yeah.
This is 5 or 4.28.
Yeah.
What happened to our 6.28?
That's just 0.
Oh yeah.
Okay.
Okay.
Okay, cool. So can you explain what's happening at each of your steps?
Okay. This is our first step.
And how it relates to height and distance? or
Yeah.
angle measure.
Okay, our first stop, which is 1R, it's the first radian. It's right here, and you see the height right here.
Mm-hmm.
It's increasing the quickest. So it's increasing the fastest, so it's a little bit.
And like that's measuring from like right here down to the midline.
Oh, okay, I see.
Yeah.
Never mind, the steepness doesn't matter actually.
Yeah.
So this is just the height right here.
Mm-hmm.
So it's the height at 1 radian. And then, so 2 is the height at 2 radians right here.
Mm-hmm.
Mhm.
The height from the midline to 2 radians, which would be taller because 2 radians is closest to the
It'd be closer.
maximum height. And then 3 is 3 radians, and this is where it's decreasing.
Mm-hmm.
So it's right here.
Mm-hmm.
And these ones are closer together because that's where our less than a radian comes in.
Oh, okay.
So it's 1 radian, 2 radians, and then it goes to 2.28.
Yeah.
Reminds me of a Dr. Seuss book. 1 radian, 2 radian, 2.28 radian.
And it's like a little piece
Yeah.
because, oops, sorry.
Oh, no worries.
Because each circle is almost 6 radians, but not quite.
Mm.
It's 0.28 more than that.
Yeah.
Because it's 2 pi.
Mm.
And then here's our little
Little
itty bitty.
guy.
This one is 3.28.
So it's like
So
right
this one
there.
is, where was it?
It was here. It might be a little off, I think, because I
Oh,
think
yeah.
the Sharpie was thicker, and so it.
Oh,
Yeah.
okay. And that's
But
right
it's
here. It's supposed to be a little bit bigger than that, but
but it's like I think it was
We were
you
using
measured like
pipe
from the
cleaners.
bottom of like the Sharpie.
Yeah.
And so you just cut off some of the Sharpie. That's okay.
Mhm. And this one.
That was 3.28. Yep.
Okay, and then this is 4.28,
So from 5.
which is measure it down from here.
From the midline to that point,
Mm-hmm.
which is the 5th stop.
Yeah,
Oh, this one is moved. Move him back.
and then this one
This
is
Is the 6th stop.
5.28 or the 6th stop.
Mm-hmm.
And then the 7th stop, which is 6.28, goes back to 0. So we don't have a pipe cleaner for that
Yeah.
one. So it was just
Because it's just
Sine
the full 360 right
Yeah.
so it would be it's just like measuring from here to here.
there.
I see.
Yeah.
That
There's
makes
nothing
sense.
there.
In this episode, Claire and Mary continue to work on creating a graph that shows the relationship between a fly's height above the midline and her angle of rotation as she travels along a circular path. To do this, they first labeled on their graph the angle of rotation that corresponded to each stop. Then they used pipe cleaners that were cut to the fly's height above the midline at each of the stops to indicate where several points would be on the graph. In the next episode, they add more points to their graph by considering several more stops.